Now I remember, I like this picture. Get it? It's a sink, and it's a tank.
Yes, I do get it.
Come on, that's funny. That's trig identities right there. That's funny. Okay. All right. So today we're going to be solving trig equations. Definitely want to have out your identity sheet. Not so much for the identities today, but a lot for the backside for the unit circle today. I remind you that tomorrow is a formative, and that you should be well into your. Oh gosh, at least 2, maybe even 3 pages worth of your 7-page homework packet by now. Okay? So, little motivation to start today. Oh, I like today's International Cheetah Day. I put it on the next slide because I wanted a big picture of the cheetah. Okay? Yeah. The day of the cheetah. Meow. I don't know if the cheetah says meow or not, but it's a cat, so we're going with it. Okay? All right. So, today we're going to have an equation, which is different than what we've had so far. So far, we've had expressions, no equal sign. That's how you know if it's a solve or if it's a simplify. If there's an equal sign, you are solving it. And we are always going to solve it between 0 included and 2 pi excluded, which on the unit circle is first positive lap. And we're just not doubling up here at 0 and 2 pi because they're the same spot. Okay, that's all that means. So first lap, you're looking for everything. Okay? So if I'm looking at this first one, okay, what I'm really thinking in my brain is I'm thinking about this, and I have a think box here just for thinking about this. I'm thinking this is 3y minus 2 equals y. And I want to solve for y. Okay? So in my think box, how would you go about solving that for y? Subtract 3y from both sides? Okay. All right. So we would subtract 3y from both sides. And then that would give us negative 2 equals negative 2y. And then what? Divide by negative 2. And then that would give us 1 equals y. Right? You have probably done thousands of those since you started, even before you started in Algebra 1. Okay? All right? You've done lots and lots and lots and lots of those. Okay? This, today, is no different than, or getting, I should say, let me rephrase that, because it is a little different in the end. But to get to this part where you've got it solved is no different today than it has been in the past. Okay? So now here, I'm going to, oops, come back to me. I'm going to subtract here 3 cosine of x. Or, as we did up there, subtract 3y. It's legal as long as I do it to both sides. Okay? So then that gets me negative 2 equals negative 2 cosine of x. Then we divided by negative 2. And so we got 1 is equal to cosine of x. With me? Now here's where it differs. Okay? In algebra, we would just stop right there. Y equals 1, we're done. Move on to the next problem. Okay? in trig, we get that expression or that equation there. Now we got to go to the unit circle, where first positive lap is cosine equal to positive 1. At 0, right? Okay. So x here is 0. If I plug in a radian measure of 0 radians into my original equation, I get a true statement. Okay? Let's try number 2 together. What would you do if, again, in your brain, you're thinking of this as 3y plus 2 equals y plus 1. If we were the green one, what would you do first? Bless you. So you subtract cosine from both sides? Okay. I'm cool with that. Minus cosine of x here, minus cosine of x there. So then this cosine has gone away. What do I got now? Left side. 2 cosine x plus 2. Next. Subtract 2. Love it. 2 cosine of x equals negative 1. Next. Divide by 2. Cosine of x equals negative 1/2. So now we got to go to the unit circle, and we say to ourselves, self, where on the unit circle, first positive lap, is cosine equal to negative 1/2? 2 pi over 3? Is that it? Is that it? Where else? 4 pi over 3? And both of those are the answers. Okay? Questions, comments, concerns, clarifications? All right, let's kick it up a notch. Now we've got multiple trig functions in our equation. Actually, hold on. Oh, no, we're at 3. Okay, I just wanted to make sure that there wasn't one more stuck way down here. Every once in a while, we'll hide one down way at the bottom, and I forget to scroll down. Okay, now we've got multiple ones. Now, when there's multiple ones, if you can get it to a single solitary trig function, great, grand, wonderful. Okay, love it. If you can't get it down to a single solitary trig function, then you got to think about this one. Again, if we think about this one as, oops, I was in green on my think box. Square root of 2xy minus x equals 0. If we think about it algebraically, and truthfully, honestly, I don't even care about the square root of 2 right now. Okay? We can just forget about that. We can just go xy minus x equals 0. What would we do? What tools do we have in our toolbox to solve that? Okay, but can we combine them? Can't combine them because xy is different than x. No, because that's just, you could do that if you had two equations. Okay? No, I want to keep everything. If we can keep it equal to 0, that'd be great.
Factor.
Love it. There it is. Factor. So we could factor here out an x. And I'm left with y minus 1 equals 0. With me? Why is that important? Now, here in math, in algebra, why is this, when we've got two different variables, why is that important? What would your next step be in algebra there? We'd set each of those factors equal to 0, right? So then we would say here, x equals 0 and y minus 1 equals 0, and then we can solve from there. With me? Okay? All right? So over here, both of these have a tangent in them. So I'm going to factor out a tangent of x. If I factor out a tangent of x, then that's the square root of 2 times the cosine of x minus 1 left over. With me on that? Get out of your way. No, you're fine. You're fine. I was just getting out of your way so you can see. Good so far. Okay? Now that I've got it equal to 0, and that's the key, Connor, why we didn't move that x over to the other side, because we can't put the factors equal to 0 if it's not equal to 0. Okay? So now I'm going to say tangent of x, let's go pink. I'm going to say tangent of x has to equal 0, and the square root of 2 cosine of x minus 1 has to equal 0. Over here, I would add 1. That gets me the square root of 2 cosine of x equals 1. I would divide by the square root of 2. That would give me cosine of x equals 1 over the square root of 2, or by now you should know that 1 over the square root of 2 is square root of 2 over 2. Okay? So now I'm looking, where does tangent equal 0? Tangent equals 0 when what happens? Tangent is what over what? Sine over cosine. So tangent is equal to 0 when? When sine is 0. Where is sine 0? 0 and pi. Okay. Cosine is square root of 2 over 2. Where? Pi over 4. Anywhere else? 7 pi over 4. So ideally, we would give those answers then in going around the circle order. Okay, so in numerical order. So for me, ideally, this would be answers of 0, pi over 4, pi, and 7 pi over 4. Would be how we would ideally want our answers written, just to make it a little easier on Schmelling. Okay? Questions, comments, concerns, clarifications? Check and see if I got one trapped down here. Nope, don't have one trapped down there. Awesome sauce. You try that one. What'd you do first? Move the 3 over. Okay. Then that left you with 4 cosine squared of x equals 3. Then? No, not yet. Divide by 4 first. That gives you cosine squared of x equals 3/4. Now we can square root both sides. Okay? We can't square root until because if this weren't a perfect square, then we wouldn't be able to necessarily do it. It is in this case, so we could have, but it's just easier to divide by 4 first. Left side gives me cosine. Right side, what does it give me? No. Say it loud. Plus and minus. We are introducing the square root, so therefore the plus or minus comes into play. Okay? So cosine is equal to positive square root 3/2, where? Pi over 6 and 11 pi over 6. Cosine is equal to negative square root 3/2, where? 5 pi over 6 and 7 pi over 6. So in order, we got that. Good? I think there's one that's tucked down underneath here, but you just never know. Gotta check either way. Oh, yeah.
Oh, gosh.
You want to try it on your own, or you want to do it together? Do we got it?
Yes.
Yeah? All right. I'll let you go. I'll let you. Hey. So, sine and cosine are our, like, main ones, right? Okay? That's what we always want to get down to, sine and cosine, because it's boom, it's right there on the unit circle for us. Okay? When you see a sine squared or a cosine squared, and the other one is a singleton, switch them. Meaning, switch sine squared here. Do we have an identity for sine squared?
1 minus cosine squared.
1 minus cosine squared. And now, what is this new? Why does that help us in that new line? Because now we can do what? Because now we can factor, because now it's all one trig identity. Okay? So we can distribute the 2 here. So we would get 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. With me so far? Okay? So that's going to be negative 2 cosine squared of x plus 3 cosine of x minus 1 equals 0. If I'm going to factor, I like to have my a value, that lead coefficient, I like that positive. Makes life a whole lot simpler. So before I factor, I'm going to say that this is 2 cosine squared of x minus 3 cosine of x plus 1. Okay? Now, how would I factor this one? Can I factor out a cosine? Why not? Because there's a 1. So I can't just straight up factor out a cosine. So what am I left with then in terms of factoring? Two sets of parentheses? Butt cheek factoring? First is going to be 2 cosine and cosine. Last is going to be 1 and 1. Do I want plus signs, minus signs, or a crazy combo?
Minus.
Well, first one is what?
Oh, yeah,
They're
they're both minus.
both minuses. Okay? They both had to be the same because it was positive 1. So that's why when I said crazy combo and you guys went with crazy combo, I'm like, whoa, tap brakes. Okay? All right. So now we say to ourselves, 2 cosine of x minus 1 equals 0. So cosine is 1/2. And we say cosine of x minus 1 is 0. So cosine of x is 1. Where is cosine 1/2? Pi over 3? 5 pi over 3? Where is cosine positive 1? 0. So I would say here 0, pi over 3, 5 pi over 3.
On the test, could we get points taken off if those aren't in like order?
No. It just makes it easier on me to grade it, but, and then I, don't get mad when I'm grading it, and then I grade it easier, you know what I mean? So big call. I wouldn't though, for your homework, I'm okay with you just circling down here. You know what I mean? But on a test, we always have that answer blank for you, so it's just easier to put it in numerical order in that answer. Okay. Love it. Oh my gosh, look at you guys got half an hour work time today. Love it. All right, so in terms of homework now, okay, you are 1 through hold on, solve, okay, yeah, so those are solved. So we're through 22, we're through 26, we're through 33. You guys are everything in the homework packet now except 34 through 37. Okay? So the whole homework packet is available to you. What did I say? 33 through 37? 34? 33 is at the bottom of the ones? Okay, 34 through 37. The only way you are going to get better at this stuff is by doing this stuff. Okay? So I have no problem giving you a half an hour work time if you're working.